What if the greatest rally victory in motorsport history was won by a car that everyone dismissed as a joke? Picture this. January 1967, the French Alps, minus 20 degrees Celsius, and a Swedish sedan with the horsepower of a modern lawn tractor is about to humiliate Porsche, BMW, and every factory team that showed up with unlimited budgets and engineering departments larger than Saab's entire workforce. This isn't a story about luck. This is a story about why sometimes the smartest engineers in the room are the ones everyone thinks are crazy. The 1967 Monte Carlo Rally should have been impossible for Saab. Their entry, the 96, produced exactly 90 horsepower from a three-cylinder, two-stroke engine that sounded like an enraged beehive. To put that in perspective, a 2010 Toyota Corolla made more power. The tires were bias-ply technology that dated back to the 1940s. The competition brought sophisticated machines with double the horsepower, advanced suspension systems, and factory support that could rebuild an entire car overnight. On paper, Saab didn't belong on the same mountain as these titans. On ice, they proved that paper means nothing when physics is on your side. Let's rewind to understand why this victory rewrote everything the automotive world believed about performance. The mid-1960s rally scene operated on a set of assumptions that everyone accepted as gospel truth. Power wins races. More cylinders mean more reliability. Rear-wheel drive is essential for proper control. Front-wheel drive is a compromise for economy cars, not something serious competitors would consider. Complex engineering beats simple solutions. These weren't just opinions. They were the foundation of how every major manufacturer approached motorsport. Saab looked at these assumptions and asked a question that changed everything. What if everyone is optimizing for the wrong problem? The Monte Carlo Rally wasn't a drag race. It wasn't even a traditional circuit race where the fastest car wins. This was a concentration rally, a test of endurance, navigation, and survival across some of the most treacherous roads in Europe. Competitors started from different cities, drove through multiple countries, and converged on Monte Carlo for special stages on mountain passes where one mistake meant a 1,000-foot drop into a ravine. The 1967 event would prove particularly brutal. A cold snap turned the Alps into a skating rink. Organizers selected the most vicious routes possible, including passes with 34 consecutive hairpin turns where ambient temperatures could kill an engine and road conditions could kill a driver. The conventional approach was to throw power at the problem, build the biggest engine that regulations allowed, add sophisticated suspension to handle the power, hire the best drivers, and hope mechanical reliability held up long enough to reach the finish. Porsche arrived with their 911, a rear-engined marvel producing 160 horsepower from a flat six that represented some of the finest engineering in Stuttgart. BMW brought their 1800 Ti, a sedan transformed into a rally weapon with a high-revving four-cylinder and suspension tuned by competition veterans. The Mini Cooper S arrived as defending champion, a giant killer in its own right, with nimble handling and proven rally pedigree. Lancia fielded the Fulvia HF, a technical masterpiece featuring a narrow-angle V4 and sophistication that made other cars look primitive. Ford sent the Cortina Lotus, with a twin-cam engine developed by racing legend Colin Chapman himself. Then there was Saab, a company that had been manufacturing automobiles for exactly 17 years. Before that, they built fighter planes. This detail matters more than you might think. When aircraft engineers design something, weight is the enemy. Complexity is a liability. Redundancy is survival. Every component must justify its existence. Saab brought this mentality to automotive design, and nowhere was it more evident than in the 96. The car looked like it had been shaped by wind rather than styled by designers. That bulbous, egg-shaped body wasn't an aesthetic choice, it was pure function. In Saab's wind tunnel, formerly used for testing aircraft, engineers had refined that peculiar shape to achieve a drag coefficient of 0.35. Most competitors were pushing through the air with coefficients above 0.45, effectively trying to drive bricks at 100 miles per hour. The Saab sliced through air resistance with 20% less drag, which meant their modest engine could maintain speeds that more powerful cars achieved by brute force. Under that aerodynamic shell sat the engine that made journalists snicker, an 841 cubic centimeter three-cylinder two-stroke producing 90 horsepower at 5,000 RPM and 88 pound-feet of torque at 3,500 RPM. These numbers were laughable compared to the competition, but numbers on a specification sheet don't tell you how an engine behaves in the real world, and the two-stroke had characteristics that conventional four-stroke designs couldn't match. A two-stroke fires on every revolution instead of every other revolution. This created torque delivery so smooth and immediate that throttle response felt telepathic. Maximum torque arrived at just 3,500 RPM, giving the Saab surprising punch accelerating out of the slow hairpins that dominated Alpine rally stages. The power curve was flat and wide, meaning drivers could stay in gear longer and spend less time shifting when both hands needed to be managing a car on ice. The mechanical simplicity was even more important than the power characteristics. A two-stroke has no valves, no camshaft, no timing chain, no complex valve train. The entire engine weighed 85 pounds, roughly half what competitors' four-cylinder engines weighed. This wasn't just about overall vehicle weight, it was about where that weight lived in the chassis. Saab mounted the engine longitudinally ahead of the front axle, with the transmission positioned behind it. This unconventional layout achieved something remarkable. With driver and navigator aboard in rally trim, the 96 had nearly perfect 50-50 weight distribution front to rear. Every other competitor was either nose-heavy or tail-heavy, dealing with the handling compromises that imbalance creates. The front-wheel drive that journalists mocked became a weapon when roads turned treacherous. All the weight pressed down on the driven wheels, maximizing available traction. In rally conditions where traction is everything and power means nothing if you can't put it to the ground, this was a fundamental advantage. The suspension revealed more aircraft thinking. Saab used a dual wishbone setup at the front with nearly 8 inches of wheel travel, extraordinary for a road car in 1967. The rear used a simple beam axle with coil springs, deliberately chosen for its durability and predictable behavior. While competitors ran stiff suspensions that kept tires planted on smooth surfaces, the Saab's compliant setup absorbed the brutal impacts and compressions of mountain passes, keeping those bias-ply tires in contact with ice and snow when it mattered most.
The steering geometry incorporated another subtle innovation. As the car rolled in corners, the suspension geometry created negative camber on the outside front wheel, tilting the top of the tire inward. This increased the contact patch exactly when cornering forces were highest, giving drivers more grip at the limit without any electronic intervention or complex mechanical systems. It was passive, it was elegant, and it worked every single time, regardless of conditions. The man Saab chose to pilot this unconventional machine was himself a study in defying expectations. Erik Carlsson, known throughout Europe as Carlsson på taket, literally Carlsson on the roof, had earned his nickname the hard way by rolling cars spectacularly in previous rallies. But those crashes had taught him something valuable about the limits of physics and the importance of knowing exactly where those limits lived. Carlsson wasn't just a driver, he was an engineer who understood every component of his car, every characteristic of its handling, every quirk of that unusual two-stroke engine. He had spent months testing the 96 in Swedish winter conditions, developing a driving technique that exploited front-wheel drive's unique characteristics rather than fighting against them. Where rear-wheel drive pilots used aggressive throttle to rotate their cars through corners, creating dramatic sideways slides that looked spectacular but scrubbed speed, Carlsson developed what he called controlled understeer. He would enter corners at speeds that seemed suicidal, using the front-heavy weight distribution and front-wheel drive's natural understeer as a safety valve. As the front tires began to push wide, he would modulate throttle precisely, pulling the car through the apex with tiny steering corrections rather than violent inputs. The technique looked smooth, almost boring compared to the heroic opposite lock antics of rear-wheel drive champions. It was also significantly faster on ice and snow, where momentum conservation mattered more than peak cornering force. His navigator, Gunnar Palm, was equally crucial to the equation. Rally navigation in 1967 required interpreting pace notes while bouncing through rough terrain at racing speeds, maintaining time schedules accurate to the minute across thousands of kilometers, and keeping the driver informed of conditions ahead without distraction. Palm had developed an economy of language with Carlsson, communicating complex corner sequences with minimal words, allowing Carlsson to maintain focus on the constantly changing grip levels beneath the tires. The 1967 Monte Carlo Rally began on January 18th with 237 entries starting from 9 different European cities. Carlsson and Palm departed from Oslo in Norway, one of the northern routes that would subject them to the worst weather conditions from the very beginning. The first challenge came before they even reached the Alpine stages. A massive blizzard system moved across northern Europe, turning highways into ice fields and visibility into a lethal guessing game. Within the first night of driving, 43 cars had retired with accident damage or mechanical failures. The sophisticated factory teams were discovering that their complex machines didn't appreciate extreme cold. Fuel injection systems iced up, electronic ignition systems failed. Complex valve trains with tight tolerances seized as cold oil became too thick to flow properly.
The Saab's primitive two-stroke engine, with its simple magneto-ignition and petroil lubrication system, laughed at the cold. The oil mixed directly with gasoline, like a chainsaw or outboard motor, eliminating any lubrication system that could fail. The magneto-ignition required no battery, no complex electronics, just magnets and coils that worked regardless of temperature. When competitors were pouring boiling water over engine blocks trying to get cold motors to turn over, Carlsson fired the Saab on the first turn of the starter motor every single time. This wasn't luck. This was deliberate engineering for worst-case scenarios. By the time the surviving entries converged on Monte Carlo for the special stages, attrition had been savage. Only 141 cars remained from the original 237 starters. The rally's reputation as the toughest event in motorsport wasn't exaggeration. It was selection pressure in mechanical form, eliminating anything that couldn't handle punishment. The special stages would make the transit sections look like a pleasant drive. The organizers had chosen routes specifically designed to break cars and humble drivers. The Col de Turini, the rally's most famous stage, featured 34 hairpin bends climbing through forests where the sun never reached the road surface. Ice accumulated in layers, polished smooth by previous competitors until it resembled a bobsled run more than a road. Weather conditions for the 1967 event were the worst in recent memory. Temperatures had dropped to -20 Celsius in the high passes. Fresh snow covered the ice, creating a 2-layer trap where cars would break through the snow and find zero traction underneath. The wind had sculpted drifts that could hide the road edge, and in many sections there was no guardrail between the road and a vertical drop into darkness. Rally organizers briefly considered cancellation, but decided to proceed. This was Monte Carlo. Suffering was tradition. The first runs through the special stages claimed victims immediately. A Porsche 911 misjudged a corner entry speed and slid backwards down the mountain before wedging itself between trees, the crew escaping with minor injuries, but the car destroyed. 2 Mini Coopers, so dominant in previous years with their nimble handling, found their short wheelbase and rear weight bias made them unpredictable on ice. Both spun off on the same corner within minutes of each other. The BMW entries were struggling with their powerful 4-cylinder engines, overwhelming the rear tires, breaking traction every time drivers tried to accelerate out of the tight hairpins. The Lancia Fulvias, technical masterpieces on dry pavement, were discovering that sophistication doesn't help when sophistication can't find grip. Carlsson attacked the Turini like a man who knew something everyone else had missed. The 96's front-heavy weight distribution, a liability on dry pavement, became a massive advantage on ice. The front wheels bit into the snow while competitors' rear drive cars scrabbled uselessly for grip. The long travel suspension absorbed the vicious compressions and sudden drops that launched other cars airborne. That peculiar egg-shaped body proved incredibly strong when Carlsson inevitably made contact with snowbanks, the aircraft-inspired construction with its reinforced passenger cell shrugging off impacts that would have crippled conventional designs. But this wasn't just about surviving. Carlsson was setting competitive stage times that shocked the factory teams. On the Col de Turini's first night run, he posted a time 7 seconds faster than the nearest competitor. 7 seconds doesn't sound dramatic until you understand that in rallying, 1 second per kilometer is considered a significant gap. The Turini was 32 kilometers long. Carlsson had just humiliated the entire field by a margin that suggested he was driving a different rally than everyone else. The two-stroke engine's instant throttle response allowed him to make microscopic corrections mid-corner. When the rear stepped out, a tiny lift and stab of throttle brought it back in line. The engine note, that distinctive ring-ding-ding sound of a two-stroke at full song, echoed off the canyon walls as the little Saab rocketed through sections where others were tiptoeing in survival mode. The French spectators who lined the stages initially dismissed the Swedish car as comic relief. Here was this bulbous oddity with an engine that sounded like a malfunctioning sewing machine being driven by a tall Swede with a permanent grin. They expected entertainment of the wrong kind, watching this economy car struggle while the proper sports cars demonstrated how rallying should be done. What they witnessed instead was a masterclass in physics defeating horsepower. Corner after corner, stage after stage, Carlsson made the 96 dance on ice with a precision that made the powerful factory cars look clumsy and uncertain. The crowds began to change their tune. By the second night of special stages, they were cheering for the Underdog. The second day brought no relief from the brutal conditions. If anything, the weather worsened. Black ice formed on corners where daytime temperatures had barely risen above freezing before plummeting again after sunset. This invisible menace was more dangerous than obvious ice because drivers couldn't see it coming. The attrition rate climbed toward 50%. Porsche lost 2 more cars to accidents, one rolling completely after hitting a patch of black ice at the exit of a fast right-hander. The BMW team suffered fuel system problems in the high altitude, their carburetors unable to maintain proper mixture in the thin air. Mini Cooper's lead car crashed heavily when the driver misjudged a braking point, ending their title defense. The Ford Cortinas were nursing sick engines, the sophisticated twin-cam design proving fragile under the constant stress of rally conditions. Meanwhile, Carlsson and the 96 maintained their relentless pace. The mechanical fuel injection system Saab used, essentially a primitive throttle body setup without complex electronics, had no problem with altitude changes. The two-stroke engine actually ran better in cold, dense air, the additional oxygen improving combustion efficiency and adding a few extra horsepower that the specification sheet never mentioned. Every component of the car was performing exactly as Saab's engineers had designed it to perform, which was the highest compliment any engineering team could receive. Nothing was overheating, nothing was breaking, nothing was wearing out prematurely. The 96 was as strong on day 2 as it had been at the start, while competitors were holding together machines that were gradually disintegrating under punishment. The penultimate day featured the Col de la Cayolle, a stage that many drivers considered even more dangerous than the famous Turini. This was a nightmare of narrow roads barely wide enough for one car, blind corners where you couldn't see if another competitor had crashed and blocked the road, and sheer drops with no barriers where mistakes were measured in vertical feet fallen rather than horizontal distance traveled. Weather conditions were approaching whiteout territory, with visibility down to 30 meters in some sections. This was where Erik Carlsson delivered what many historians consider one of the greatest individual stage performances in rally history. In conditions where rational drivers would back off and accept that survival mattered more than stage times, Carlsson attacked with absolute commitment. The 96's excellent weight distribution and predictable handling allowed him to carry incredible speed through corners he could barely see. Palm was calling pace notes into what felt like a void, trusting that Carlsson would keep them on the road through instinct and mechanical sympathy when visibility made conventional driving impossible. They completed the Cayolle stage 4 minutes and 17 seconds faster than the next competitor. 4 minutes and 17 seconds! In rallying terms, this wasn't victory. This was a statement that the competition wasn't even driving the same event. The Porsche team manager reportedly refused to believe the timing officials, insisting they had made an error. The times were checked and rechecked. No error existed. The little Swedish car, with its laughable 90 horsepower and ancient tire technology, had just destroyed every sophisticated machine on one of the most challenging stages in motorsport. The French scrutineers, who had been quietly amused by Saab's entry, were no longer amused. They were witnessing something that challenged fundamental assumptions about automotive performance, and the implications were making established manufacturers very uncomfortable. Going into the final day, Carlsson held a commanding lead of nearly 9 minutes over the second-place car.
But the Monte Carlo Rally had earned its fearsome reputation by crushing dreams on the last day, and 1967 would be no exception to the tradition of late drama. The final stages were a series of short, intense tests around Monaco itself, designed to create last-minute excitement for spectators and give powerful cars one final chance to make up time. These stages favored raw acceleration and top speed, exactly where the 96 should have been most vulnerable. A Porsche could hit 130 miles per hour on the straights. The Saab topped out at 95. On paper, this was where the deficit would matter. But Carlsson had been managing his equipment throughout the entire rally, never quite pushing to absolute maximum, always leaving a small margin for safety. The two-strokes mechanical simplicity meant that as long as you maintained proper oil ratio in the fuel and didn't exceed redline, the engine would run indefinitely. While competitors were nursing sick power plants, failing transmissions, and damaged suspension components, the 96 was mechanically sound. Carlsson didn't need to win these final stages, he just needed to finish without disaster. The competitive fire that had driven him to attack every other stage suggested he might have trouble with a conservative approach. On the Monaco Harbor stage, with thousands of spectators packed along barriers and filling grandstands, Carlsson gave them a demonstration they would discuss for decades. The little Saab looked impossibly small next to the yachts and architecture, an economy car and a millionaire's playground. Carlsson threw it through the concrete canyon at absolute maximum attack, the two-stroke engine screaming at redline, the characteristic blue smoke of oil burning mixing with tire smoke as he power slid through corners designed for Formula One cars. The crowd went berserk. This wasn't the safe approach of a points leader protecting an advantage. This was a driver and machine in perfect harmony, extracting every possible fraction of performance, because that's what they came to do.
When the checkered flag dropped on January 24, 1967, Erik Carlsson and Gunnar Palm had accomplished what the entire motorsport establishment had considered impossible. They won the Monte Carlo Rally outright in a car with 90 horsepower and bias-ply tires. The final margin was 8 minutes and 47 seconds, an eternity in rally competition. Of the 237 cars that started, only 62 reached the finish. The Saab 96 hadn't just survived, it had dominated in conditions that destroyed sophisticated machinery from manufacturers with 100 times Saab's budget. The immediate reaction from the motorsport world split along predictable lines. The French press, initially dismissive, suddenly couldn't write enough about the Swedish sensation. L'Equipe ran a front-page headline calling it the most improbable victory in rally history. British magazines struggled to explain how a car they had barely mentioned in pre-race coverage had embarrassed every established name in the sport. The technical journals began dissecting the 96's design, suddenly recognizing that unconventional didn't mean wrong, it meant different, and in this specific application, different had proven superior. For Saab, the victory was transformational. Sales of the 96 exploded across Europe. Dealerships couldn't maintain inventory. The car that had been dismissed as an oddball economy vehicle was suddenly desirable, a proven giant killer that ordinary people could own. Saab capitalized brilliantly with special Monte Carlo edition models and advertising campaigns that emphasized their rally success. But the deeper impact went beyond sales numbers. The 1967 Monte Carlo victory established Saab's reputation for building safe, reliable, surprisingly capable cars. That reputation would define the brand for decades. The technical implications rewrote rally car development. Front-wheel drive, universally dismissed before 1967, suddenly looked like the future for rally competition. Within 3 years, nearly every manufacturer was developing front-wheel drive rally programs. The idea that lightweight engineering could triumph over raw power gained credibility that changed how engineers approached competition car design. Simplicity and reliability in endurance events became priorities rather than afterthoughts. The Saab 96 proved that understanding the actual problem mattered more than following established conventions, and that lesson echoed through motorsport for generations. The two-stroke engine's success was bittersweet. While it proved the design could be competitive at the highest level, emissions regulations were already spelling doom for two-stroke technology in automotive applications.
Saab themselves abandoned two-strokes by 1968, switching to a Ford-sourced V4 engine. But that peculiar three-cylinder had served its purpose magnificently, demonstrating that unconventional thinking could overcome conventional power when applied intelligently to the specific challenge at hand. What made the 1967 victory genuinely revolutionary wasn't just that an underdog won. Underdogs occasionally triumphed through luck or circumstances. What made it revolutionary was that the Saab won by being fundamentally better engineered for the actual conditions of the event. Every design choice that looked like a compromise on paper proved to be an advantage in reality. The modest power didn't matter when aerodynamic efficiency meant maintaining speed with less effort. The bias-ply tires worked beautifully when the suspension kept them properly loaded. The front-wheel drive excelled when traction mattered infinitely more than power. The simple engine ran flawlessly when complex motors failed. This wasn't luck. This was engineering excellence applied to the right problem. Erik Carlsson's driving was the final element that transformed good engineering into historic victory. His understanding of the machine, his development of techniques that exploited its strengths rather than fighting its characteristics, and his absolute commitment to extracting maximum performance made the difference between a good result and domination. The 96 needed Carlsson, and Carlsson needed the 96. Together, they proved that the whole could exceed the sum of already excellent parts. The legacy lives on in unexpected ways. Modern rally cars, with their sophisticated all-wheel drive systems and turbocharged engines producing over 400 horsepower, might seem to have nothing in common with that humble Swedish sedan. But look closer at what engineers prioritize: weight distribution, aerodynamic efficiency, reliability over raw performance. These are lessons learned from a frozen mountain pass in 1967, when a car that shouldn't have won proved that different thinking beats conventional wisdom when different thinking is actually correct thinking. The 1967 Saab 96 didn't just win a rally, it won an argument about what engineering excellence really means.